Welcome, my dear students. Muhammad Said with you, physics teacher. Today we are going to talk about electrical current and Ohm's law. To understand what's meant by electricity or the basics of electricity, we have three main basic concepts. Electricity, there are three main concepts. The first one, electric current. And later we are going to talk about electric current intensity. Then the second concept is electric potential. And later we are going to talk about electric potential difference. And the third concept is electric resistance. These are the main basics of electricity: electric current, electric potential, and electric resistance. Now we are going to talk about the first concept, which is electric current. Actually, what's meant by electric current? Electric current, number one, electric current. What's meant by electric current? Now we are going to define the electric current, then we are going to explain what's meant by electric current. Electric current, it is the flow of electric negative charges like electrons for example, electrons within or through electric conductors. Okay, what's meant by electric conductors? We have learned before that materials are divided into or classified into two main groups: electric conductors and electric insulators. Electric conductors and electric insulators. What is the difference between them? Electric conductors, they are the materials that allow electric current to flow through them, like metals, iron, gold, silver, copper. And electric insulators, they are the materials that don't allow electric current to flow through them, like non-metals except carbon. Okay, what is the difference between metals and non-metals? What is the difference between metals and non-metals? Metals allow the electric current to flow through them. Why? Because we have learned before that in the modern periodic table, metals lie at the left side of the modern periodic table. So we said that the atomic size decreases gradually as we go from left side to the right side in the modern periodic table. Metals and so on. So metals lie at the left side. So the atomic size of metals is larger than that of non-metals. So the attraction force between nucleus and outermost electrons is very weak. They are loosely bonded to the nucleus. So they are called free electrons. Which means that these electrons can move from one atom to another. So metals have the ability to conduct electricity because they have free electrons. While non-metals, their atomic size is very small, so the outermost electrons are strongly bonded to the atom. So they can't move from one atom to another. So they can't conduct electricity. Okay? Okay, we said that electric current, it is the flow of negative charges within electric conductors from one point to another. Okay, there are two types of electric current. If we have a battery, electric source, positive pole and negative pole. So resistance like a lamp, for example. We have two types of electric current. conventional current this is called conventional current. It is the flow of the electric current from positive pole of the battery or the electric cell towards the negative pole outside the electric source. So this is called conventional current. While the actual current, it is the flow of electrons in this direction. So this direction is called electron or actual current. Okay, what mean by actual current? It is the flow of electrons from negative pole of the source towards positive pole outside the electric source. It's called actual current or electron current. It is the flow of electrons, so it's called actual current. But the conventional current is the flow of electric current from positive pole towards negative pole outside the source. Conventional current, actual current. Okay? Now we talked about electric current. What's meant by electric current intensity? Now we're going to talk about electric current intensity. Okay, electric current intensity. If we have two electric cells, for example, in this electric cell, it has created greater electric current, while this cell, this circuit has smaller. What is the difference between them? Electric current intensity, it is the number of electric charges. If we have consider this wire, inside the wire there are electrons move from the point of higher electric potential towards the point of lower electric potential. So electrons move inside this wire. Okay, what is the difference between this circuit and this circuit? In this circuit, the number of electrons okay, in this case, the number of electrons or number of quantity of charges that flow through a cross-section area is smaller than the number of charges or quantity of charges that flow through a cross-section area in 1 second. So we can define electric current intensity. It is the quantity of charges, the number of charges, it is the quantity of charges that flow through a cross-section area in 1 second. So electric current intensity, it is the quantity of charges that flow through a cross-section area of a conductor in 1 second. So we can say that I, electric current intensity, equals quantity of charges that flow through cross-section area in 1 second. So we can get or determine the electric current intensity from this relation. Electric current intensity equals Q over T. Q, it is the quantity of charges that flow through cross-section area of the conductor in 1 second. Okay, how can we get the quantity of charges? Quantity of charges, it is the number of electrons that flow through cross-section area. So Q equals NE. N, it is the number of charges or number of electrons that flow through cross-section area in a conductor. E, it is the charge of electron, which equals 1.6 times 10 to the power negative 19 coulomb. Okay, again, I, it is the quantity of charges, it is the electric current. Q, quantity of charges divided by time. Okay, electric current intensity, it is measured by a unit called ampere. Quantity of charges measured by a unit called coulomb, and time measured by second. So what's meant by the electric current intensity at home equals 5 ampere. What's meant by the electric current intensity equals 5 ampere. What's meant by that? Electric current intensity equals 5 ampere. We said that electric current intensity equals quantity of charges divided by time. So this means that the quantity of charges that flow through cross-section area of this conductor, quantity of charges that flow through cross-section area of this conductor in 1 second equals 5 coulomb. This means that every 1 second there are 5 coulomb passed through this cross-section area of the conductor. Or in another way, there are 5 coulombs that reach the electric device in 1 second. Okay, every 1 second. Again, what's meant by electric current intensity equals 5 ampere? This means that the quantity of charges that flow through cross-section area of this conductor in 1 second equals 5 coulomb. Okay, what's meant by the quantity of charges that flow through cross-section area of the conductor equals 10 coulomb every 2 seconds. Now we have quantity of charges and time. Okay, electric current intensity equals what? Quantity of charges divided by time. So 10 divided 2 equals 5 ampere. So this means that the electric current intensity that passes through cross-section area of this conductor equals 5 ampere. Okay? Okay, again, electric current intensity is the quantity of charges that flow through cross-section area in 1 second. I equals Q over T. I current intensity, Q quantity of charges in coulombs, T is the time in seconds. Okay, ampere coulomb per second. Okay, what's meant by ampere? It is the electric current intensity due to the flow of a quantity of charges of 1 coulomb within a time of 1 second. Okay, so the definition of ampere, it is the electric current intensity due to the flow of a quantity of charges of 1 coulomb through a cross-section area of a conductor in 1 second. Okay, this is the definition of ampere. Okay, we can say that the electric current intensity at home is 5 ampere or what? Or 5 coulomb per second. Okay, 5 ampere or 5 coulomb per second, which means there are 5 coulomb passed through the cross-section area of the conductor in 1 second or every 1 second. Okay, now we are going to talk about the next definition or the next concept of electricity, which is potential difference. What's meant by potential difference? First, we are going to talk about electric potential, then potential difference. Number 2, electric potential difference. But first, we are going to talk about electric potential and what's meant by electric potential. If we have a conductor, for example, lamp, the electric current flow in this lamp, the condition that makes the electric current flow through this lamp, there must be a difference in potential or potential difference between its 2 terminals. For example, A and B, there must be a potential difference. The potential of point A is greater than point B or B greater than point A. So what's meant by electric potential? To understand what's meant by electric potential, if we have two metals, for example, hot, its temperature, it has high temperature, hot and cold, and we connect them with another metal. So what will happen? Heat will transfer from object A towards object B, right? Because there is a difference in temperature between them. So what will happen if the temperature of the two objects are equal? Sorry, is equal in this case. Hot and another object is hot. The temperature of the two bodies are equal. No transfer take place between them, right? If we have two metals, the first one has charged with has high potential, electric potential, and the other one low electric potential, and we connect them with another metal. So the charges will transfer from the object of high potential towards the object of low potential. So what is meant by electric potential is the state of the conductors. This is the state of the conductor that shows the direction of electric current from it or to it when it is being connected to another electric conductor. Okay, now we talked about electric potential. What is meant by electric potential difference? We said that the electric current flows from a point or terminal to another terminal of the conductor when there is a potential difference between them. What's meant by electric potential difference? If we have two conductors, if we have two terminals of a conductor, A and B, the electric current flows from A to B when the potential of A is greater than that B. Potential of A greater than that B. So what's meant by electric potential difference? It is the work done to transfer. If we have a battery, this battery pushes the electric current towards this direction. So it do work. So we can define the electric potential difference. It is the work done to transfer a quantity of charges of 1 coulomb between the two terminals of a conductor. Okay, again, potential difference. It is the work done by the electric source to transfer a quantity of charges between the two terminals of the conductor. So we can say that potential difference, it is symbolized by V equals work divided by Q. Potential difference equals work done to transfer a quantity of charges of 1 coulomb between the two terminals of the conductor. Okay, the potential difference measured by a unit called volt, and work measured by joule. Quantity of charges measured by a unit called coulomb. So what's meant by the potential difference at home equals to 120 volt? This means that the work done to transfer a quantity of charges of 1 coulomb between the two terminals of the conductor equals to 120 joules, which means that each quantity of charge, for example, it carries energy equals 220 joules to transfer it to the electric device. So we can say that again. What's meant by that? The potential difference at home equals 220 volts. This means that each charge is the work done to transfer each charge or a charge of 1 coulomb between the two terminals of the conductor equals 220 joule for each charge. Okay. What's meant by volt? From the relation. Volt, it is the potential difference when a work of 1 joule done to transfer a point of charge 1 coulomb between the two terminals of the conductor. This is the definition of the volt. Okay. For example, problem number 1, find the potential difference between two terminals of a conductor if a work of 440 joules done to transfer a charge of 2 coulombs between its two terminals. Okay, we said that V equals what? Potential difference equals work over Q. So work, we have work 440 joules divided by 2 coulombs equals 220 volts. Or we can say that 220 joule per coulomb. Okay? Thank you.